Hello and welcome to my channel. In this video I will be talking about the software architecture I used to create the control software for the demo production plant project you saw in the previous video. So let's get into it. As we can see on the left side, we have several numbered folders, each folder representing a separate layer in the control software. The I/O layer is responsible for exchanging data between the PLC I/O registers and the user-defined type instances I created for each device type. If we open one of these up, for example the binary I/O function, then we will see that the binary I/O function contains a network for each device that we are controlling in the production plant. If we open up one of these networks, for example the CNC machine for the metal parts, we will see that all we are doing is copying the Boolean data from the input register to the user-defined type instance that belongs to the particular device. And from the user-defined type instance, we are copying the data to the output register. And this is exactly the same thing we are doing for all the devices in the binary I/O. So let's close this up. If we examine the analog I/O, then we will see that something very similar happens. So each device has its own network. And if we open one of these up, for example the unstacker station, then we will see that we are not just copying the data from the input register to some UDT instance, but we are also normalizing the data. So on the left side we see that we have the usual analog integer representation for the particular input value, but I then scale it to a normalized percentage value, which is much easier to work with later on. The same thing happens for all the other devices as well. If we open up the HMI I/O, let's just wait for it, then we will see that here we don't have separate devices, but instead I name the networks based on what they are doing. Okay, let's close this up and let's close this too. The next layer is the data layer. Here we store all the information that is being processed by all the other logic of the control software. For example, the dev I/O data block stores the information that is being processed by the binary I/O and analog I/O functions in the I/O layer, while the HMI stores the information that is being processed by the HMI function of the I/O layer. So if we open this up, for example, then we will see that each device has its own UDT instance, but some of the UDTs are stored in an array so that we can access them by array indexing, for example. The settings data block is used to store information that is being used to fine-tune the plant's behavior. If we open this up, we can see that each device has its own settings UDT instance, and basically the plant programmer only needs to do is to open each and every one of these up and set the different parameters as they are required by the plant. Okay. The next layer is the equipment layer. This layer contains only 4 function blocks, each function block representing a specific section of the plant. In a 1500 series PLC, these individual function blocks would actually be software units, which are actually far more usable for such a problem because they can individually be updated and modified without needing to change any of the others. But since this function or this feature is not available in the 1200 series PLC, I reverted back to using ordinary function blocks. So what are these exactly? If we open one of these up, then we will see that these plant sections have subsections. Each subsection contains its own set of device control function blocks. Each function block is responsible for controlling one single device in the production plant. As we can see, we have several conveyors in here, but if we open up, for example, the next one, then we have just one of these because this is a complex device. Actually, this is a station blocks, but we will get to this later. So as you saw, the architecture is quite simple, very easy to understand. And this was actually the original plan when I created this control software, to make it as easy as possible to program with it. So if one wanted to create an entirely different plant with a completely different layout, the only thing the programmer would need to do is to throw the control blocks in a different order, in different subsections, and fine-tune the settings in the settings data block to achieve the desired behavior. I think I've finished the video right here. Thanks for watching. Bye.